Okay, so today in this video I'm going to be talking to you about EO, or edge orientation. EO is the abbreviation. I'm not going to be on and all the most efficient ways to solve EO cases and its application to the Petrus method. I'm not going to be going into ZZ and the EO line and stuff because I'm simply just not as well versed on that as I am with the Petrus method. So I'm going to be showing you all the tips and tricks and most efficient ways to solve EO cases and simply why you should do it. So without further ado, let's begin. Okay, so now I'm just going to get into a quick explanation and how to recognize bad edges. So at least EO in its application to the Petrus method, which is the method I use obviously, after you finish your first block, you move on to EO. And basically what EO is, it's edge orientation, and you would orient all the edges left in these two sides to solve the rest of the cube using R and U turns. A lot of people think EO is just a useless step. It's very vague, doesn't really look like you're doing anything. It's actually very useful because R and U turns are the easiest to do and the fastest. So the more you can do those, the better. You want to avoid as many F and B turns, at least the majority of the time, and that's why EO comes into play. So now I'm going to show you how to recognize a bad edge, which is actually very simple. If you can recognize good edges, then you can recognize bad edges. So a good edge is basically one that's one turn away from being solved to its center. So for example, these two are already solved, so you don't need to turn them out. These two are good edges, and so are these two. But for example, these two aren't solvable with one move. And the one move has to involve one of these two sides, one of the two sides that you can turn without interfering with your first block. So these two, I have to turn this side to fix it, which interferes with my first block. Same thing with this. So these two are bad edges. This is a good edge because I can do U and it's solved here. So that's how you recognize bad edges. And now I'm going to show you the most efficient ways to solve them. Okay, so now I'm going to show you the four simple two bad edge flip cases. So this is the first one. It's where your one bad edge is here and then one is here. Obviously you're holding your 2x2x3 block in the back. Your two bad edges are here. It's this simple. You fix one like this, put the other in its place, and then bring the first one down. Or you can remember as algorithm if you want, R, U prime, R prime. But really all you're doing is just bringing one up, fixing it, putting the other one in its place, and undoing. It's that simple. So that's case one, like this. R, U prime, R prime. Okay, case two is like this, where you have one bad edge here, one bad edge here. This is solvable in a very similar manner. It's just bring one of the bad edges down, putting the other one in its place, and then bring the first one up. Here it is again, R prime, F, R. One more time, bring this one down, so it becomes a good edge, put this one in its place, it's still a bad edge, and then make it a good edge. So that's case two. Okay, case three is where you have one bad edge here and then one bad edge here. And keep in mind, all these cases can be mirrored. So for example, to solve this case, it's this, what I'm about to show you is the same for solving this case. You just do it with lefty moves. And that's the same for all the cases. Same for this one, or not this one, and also, of course, this one. So all of them can be mirrored to be solved on the left side. So here's the third case, where one bad edge is here and one is here. And this is solvable like this. Bring the bad edge down, making it a good edge. Put the second bad edge in its place and undo, making the second one a good edge. Pretty simple. So R prime, F prime, R. That's the third case. Okay, so the fourth case and the final case, at least for flipping two, is like this, where you have one bad edge here and then one here. Keep in mind again that this case can also be like this, and in this case it's just solvable the same way. So it's just three moves again. Fix this, make it a good edge, put the other one in its place, and then undo. Here it is again. R, U, R prime. And that's how you solve that case. Okay, I've shown you all the cases where you flip two bad edges, but you don't always have to. You sometimes have four bad edges. What do you do in that case? Well, it's really quite simple. You just do one flip that flips two and do another. It's not that simple, but I'll show you that in a second. And you can either have 0 bad edges, in that case you have a skip, 2, 4, or 6. And notice they're all even numbers because there's 7 edges on this, and you will always have at least 1 good edge. Okay, so on to solving 4 bad edges. There's a couple of cases for this, but they're all very intuitive. For example, this case, we see this. This is one of the cases I talked about earlier. It's just the mirror of this. And we also have the 2 bad edges in this case. So we can do this first case, and then do the second one. It's really that simple. Now there are some more advanced cases that I'll go over very quickly. This isn't one of them, but okay, so something like this, where you want to do them in a certain order so that you don't get a bad case. For example, some cases where you would go like this. See, if I did it like that, if I solved these two like this, solve this one, put the other one in its place, and then put it down, that would put these two in a position where I have to do an extra turn. So just something to keep in mind is you want to view the position of the edges as in one step instead of just, oh, I see these two, I'll solve those. Oh, I see these two, solve those. That's just not as good, it's not as smooth, it's not as fast. So that you want to recognize them all in one step and then do them in another. Okay, now I'm going to show you how to solve it with 6 bad edges, the final case. And there are 4 ways you can have it positioned to solve 6 bad edges. First, for recognizing it, you'll notice that a bunch of edges are bad, and you just want to find your one good edge and put it in either this position, this position, this position, or this position. So that means it can either be here, 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 or here. Any of them work. And all of them are basically solved in the same way. First, I'm going to show you the ones where you have the bad edge here or here. They're both just solved the same way. So when you have your bad edge in one of these positions, you solve it like this. M, F, M prime. That orients 4, and then you do these two. R prime, F prime, R. Here it is again. Here it is again. So we have our 6 bad edges, and then our one good edge is in this position. So we just solve 4 of them by going like this, and then solve the other 2. That's how you solve these 2 cases. Now if you want to do one of the ones where you have one of your good edges in one of these positions, so in this case it's here, but it could also be here, you can solve it like this. So it's just the inverse. M prime, U, M, and then solve these 2. Here it is again. M prime, U, M, solve these 2. Easy. So that's how you solve all the EO cases. I didn't go into all of them, but the rest of them can just be solved with doing like one move to put it into the right position, and then you would solve it with one of the cases I showed you. So that's a simple, basic thing of EO. If you want a more advanced thing of EO, because I do know a bunch of more tricks for EO, let me know in the description, as well as just any other methods you want from me for the Petrus method, and I'll be fine to answer them. So